Hi there, I'm Kyle with iFixit.
And I'm Jessa with iPad Rehab.
So we took the iPhone board that I just repaired and we dunked it in water.
Kyle had to step outside.
I left, she put it in the water, and what did you add to the water?
So we wanted to, kind of really give a sort of a real life example of what happens to your phone when you drop it in water. And it does depend on what the solution is, which is 90% of the time urine. Come on. And
urine or cat pee or
yeah, I mean, the
is.
Toilet phones are really like most of water damage. But, now that it's sort of becoming summer, we have swimming pools and especially salt water.
I jumped into a lake once with my phone in my pocket.
Did it survive?
And it survived. I mean, I shut it off immediately. I waited a day or so. I think I took it apart just to dry it out. I put it back together and it was fine.
Right. So,
So sometimes you get lucky.
You do. And, it's kind of like, what should you do when you drop your phone in whatever kind of liquid? And, the internet tells you to put it in rice, and that is a myth. And that's what we're trying to kind of dispel. And the reason why is because putting your phone in rice is pretty much the same thing as doing nothing. You're allowing whatever the liquid is to really dry on the board. So any electrolytes, any minerals or impurities that are in the liquid are just going to dry on your board. And what you want to do instead is to displace them. So if you, no matter who you are, if you take a phone and you get it wet, then you can, follow an iFixit guide. Open it up. Get
Absolutely.
The board
The first
out,
thing you do, take it apart, get everything out.
and drop it into some kind of like isopropyl alcohol, something like that. And honestly, like there was a guy that is in the repair community, he was on a cruise, and it's sort of like, you would have been better off after his phone like fell in a pool, to just drop the entire phone in alcohol. If it's an important phone, that you'll probably have to replace the screen and the camera, but you'll be able to save the phone.
You can even use distilled water if you
have you could
to.
use distilled water, anything.
It's not the water that's necessarily the problem, it's the impurity. Water doesn't actually conduct electricity in and of itself. Water isn't corrosive in and of itself. It's all the elements that are in there. Either it's the chlorine in the pool or the ammonia in the pool, or if you jump into the ocean, your water goes in the ocean, then you've got the salt that's corroding it. So you have to get those impurities off.
Exactly. So, I like this example that we did. So we dropped this iPhone in water intact.
So the board was functional and looked fine.
Yep.
An hour ago.
Yes.
Okay.
Yep. And we looked over this. It was kind of like, hey, let's do a cool time lapse thing. Let's see what's going on. And I was surprised looking over the video that within 30 seconds you could see frank corrosion on the board itself.
So we put it in the water while it was on, and the corrosion is going to happen much faster if the device is on.
Electricity's moving through it. Yes.
So why does that happen? How does the electricity accelerate it?
Well, electricity is moving charge, and what you're kind of doing is like this electroplating kind of operation, really. So if you're combining electricity plus like charged components, little charged ions, particles, charged particles, then that is a recipe for shorting out electrical circuits, So that's kind of what happens. So let's take a look at that exact board. This is the same board that you just worked on.
I'm terrified to see what this looks like. I haven't looked at this board yet. You attacked my phone. This looks awful.
Yeah, it looks like
I can't even see the board through all the corrosion and everything. It's between every single component. It's probably shorting one component to the next. Look at those pins. Like, there's no way you could possibly connect something and get a solid connection there.
Right, and you're going to be really sad because, of course, where the phone is going to be really hit is on the power line.
So the battery connector, because you have the most current flowing through there, is going to get the most corrosion. And you can see that leftmost pin is the power pin. Yeah, and that's what saw the most. And it's acting as electromagnet. It's drawing all the particles to the pins.
It's really sad. Oh. Okay. So, so this is, really...
This is about as bad as it gets.
This is bad. Yeah, this is bad. And, so what do you do in this situation? I think the point to kind of take home with this is that this phone was fine an hour ago. We put it in, some water that had like a tablespoon of salt in it for some electrolytes in there to kind of mimic, kind of a standard solution. And this is what it looks like. We didn't do anything else to it. And that's, like if you just imagine what would happen if I had this phone, sort of intact And I hadn't looked at the board, and I just said, well, let's just put it in some rice and cross our fingers.
Right.
It's
just
done. It's already happened, So it's just going to continue to get worse and corrode over time.
Well, so the most critical thing is to turn it off.
Right.
So the first thing you want to do, you drop your iPhone or any other phone. If you have a traditional phone, just take the battery out, yank the power immediately. With an iPhone, you got to get in, and this is the battery connector. Just pop off that battery connector.
Right.
And now at least there's no current going through it, and then you can work on cleaning it.
Water damage, as far as like if you're a general repair and you're going to do water damage, this is difficult. It's sort of difficult just for the entire industry. How do we make water damage, profitable for a repair shop to do? And I think that at least in I have a strong opinion that, professional water damage cleaning means that you take the board out and that you expose the board by desoldering the shields.
Okay.
And that then you address the corrosion with a quality ultrasonic cleaner. So I want to look here at some other boards that I brought to do this with, because I brought a few because it tends to be pretty open-ended. Some of them come back, some of them don't. So we want to kind of look at a few here.
So you can see some of these shields. I've got this board. You've got all these shields. So you can see the corrosion on the outside. You can't see the corrosion underneath the shield. So we got to get those shields off.
Right.
And this is where we start to say, well, maybe we're moving beyond the realm of a DIY repair. You can try to clean it the best you can.
Right.
Clean it with alcohol, brush it, do everything.
Yep.
If you can fix it, great. If you can't, then it's time for the next level, which is desolder the shields, which will require a microscope and some fine soldering equipment. And then an ultrasonic cleaner. And we're going to talk about what that is in a minute.
Right. So here's a lot of times you'll find customers that don't realize that their board has been water damaged. So let's look at this board. Do you see that there's a capacitor here? Right there?
Yeah.
And how it's nice and shiny on one end and then dark on the other end. Same for this one. It's nice and shiny, but then dark. It should look like this one, nice and shiny on both sides.
So there's been some kind of material.
So this is water damage.
Okay.
This component right here, it should be, shiny solder on both sides. It should look just like this one here. But it doesn't. That is water damage.
And that's incredibly hard to see with your naked eye.
It is. Then look here. There's corrosion here. Mm-hmm. This stuff on the phone is actually sort of a protective coating. So that sort of protects some of those components from water damage. All along here looks fine. That's normal, normal, normal. But then when we get to this is sort of a kind of a classic spot that tends to get a lot of water damage. There's a Bluetooth Wi-Fi pieces here. That component is so water damaged that it may be non-functional. So when you're doing repair, one of the first things, when you're doing board level troubleshooting, one of the first things that you want to do is a visual examination of the board after you get that history, to sort of guide your thinking, because water damage really changes everything. It changes what you're going to be thinking about in terms of possible causes and problems.
Right. You could be diagnosing something else and realize, oh, this was caused by water damage. It's not just a routine failure.
Right. Yeah. And that happens to me all the time. I don't know how many YouTube videos that I have started that were, this is going to be about a charging system. Let me talk to you about the charging system. And then I open up the phone. It's water damage. That just people
Well,
kind of
it's incredibly common. You go running in the rain and...
Sure.
Okay, so let's talk about how to fix water damage.
Okay. So this phone then, when I see that the board has evidence of water damage, I really can't feel comfortable doing any repair until I address the water damage.
Okay.
And that always, to me, means the same thing. Taking the board out, desoldering the shields, putting it through ultrasonic cleaner.
So we've got a board with water damage. How do we fix it?
Okay, that's a really good question. We're going to desolder the shields to expose the board.
Okay,
but then
so we can get it
after that, we're going to treat it with ultrasonic frequency vibrations. So we need an ultrasonic cleaner.
So what I know about ultrasonic waves is you need some kind of medium to transmit the waves to the object. So what kind of medium are we going to use?
So we are going to use a specially formulated for electronic cleaning solution that's called Branson EC, or Branson Electronic Cleaner.
Okay. And this is a very expensive, specially formulated.
It's not super expensive, you know, and you only use it at 3%
Okay.
with distilled water.
Okay.
So it's kind of like a electronics detergent.
Okay.
You know, it just sort of helps to create the right pH in order to help kind of address the specific type of corrosion that you would get on an electronics board.
We could use distilled water, though, right? It would probably work to some extent. Distilled water with an
Distilled
ultrasonic
water
cleaner.
wouldn't be terrible. Yeah, it wouldn't be terrible, but we couldn't control the pH. It would be sort of all over the place.
Okay.
And, you know, you really sort of want to, you know, kind of control the pH because you're trying to kind of break chemical bonds, you know.
Okay. What's special about this ultrasonic cleaner?
So this is an expensive ultrasonic cleaner, and it's an investment for a repair shop that I think repair shops should make because it very easily and quickly pays for itself because it's very good. And the reason it's very good is because, you know, sound waves have different frequencies. And so ultrasonic waves in this machine are generated by sweeping through all of those different frequencies because the different components on an iPhone board are going to oscillate at different frequencies.
Right.
So if
So
you
every
change the
object-
frequency, then you'll be able to kind of shake the corrosion off a little bit.
Every object has its resonance frequency.
Yeah.
If you've seen that bridge in Washington.
Yeah.
Okay, so you find the resonant frequency of the object. You vibrate a little bit. You're going to get maximum vibration. It's going to shake
Right.
everything out. The detergent will be in there.
Right. It's
working.
really the best you can do. And, you know, honestly, this thing's expensive, and I bought it because I did not believe in it. And I wanted to I intended to make a video that was kind of like, why spend all this money? You know, like it's going to be fine to use the inexpensive jewelry style cleaner. And I was wrong. You know, I was totally wrong. I gave it a shot with some boards and
these were boards that you'd try the cheaper cleaner.
right, like boards that I had that I not just cleaned with ultrasonic, but really worked on. Like I had, you know, been under the microscope, replaced components, and I had given up and said not repairable. And then, you know, this one board in particular, I remember as soon as I got that thing, I just put it in there with Branson EC, fired it up, 5 minutes, and it turned on no problems.
Wow. All right, so you're knocking the competition a little bit.
Yes.
Let me show you what the competition is. So this is a Baku 9030 that we got off Alibaba. It's like $15.
You
This is
have
as
to
cheap as it
read.
gets.
You have to
Okay.
read the sales picture.
And the label's on here. It has microcomputer intellect control, whatever
Yes.
that is. It also has intellectualized time hypothesis.
That's my favorite. Intellectualized time hypothesis.
I don't even know what that means, although I feel like it's something that I do every day. Okay, so as I figure out how to use my intellectualized time hypothesis machine, you can
Yes.
see I can put the board in here
Right.
and fill it with liquid
Right.
and push it on, and it's
Right.
going to do some kind of ultrasonic thing.
It's gonna make bubbles, and it's gonna, you know, zzz, and it's gonna, you know, seem like you're doing ultrasonic cleaning.
And it very well might be better than nothing.
It might be better than nothing, yeah.
So if you're a consumer and you have a water damage board and you just want to try, you know, you can try
Yeah,
this
because
absolutely.
that's pretty inexpensive, and it's probably gonna be better than what I tried when I had that massager with a Tupperware of alcohol on top of it. So yeah, you know.
Obviously, there's a spectrum from the $15 ultrasonic cleaner all the way up to the $800 professional grade ultrasonic cleaner. And we're hoping to be doing some more testing and see if we can find a sweet spot somewhere in between here that might be more accessible.
You know,
for
there probably
the DIYer.
is. Well, there probably is. This is big, and it's big because I can put a MacBook board in there. You know, mostly MacBook boards. You know, and a lot of general repair shops. You know, if you're kind of like, oh, I'm not sure about board repair, and I'm definitely not sure about MacBook board repair. You know, if you take a wet MacBook board and you throw it in there, a lot of times it'll come back. It's definitely worth a shot.
Okay, so let's do a repair on. I mean, we're gonna take my incredibly encrusted board and we're gonna try to fix this one.
We're
Or are
gonna
we
do. Yep. Well,
Okay.
we can put that one through, and you know, there's no reason to not do a few of them at a time.
Okay.
So look how it's still wet under the shield.
Yeah, and this is, I was looking at it, I was like, oh, this board is dry. It's safe to power back on. Nope, you get under the shield and
Right.
sure enough, there's still moisture under there.
Right.
So the corrosion
So
is still
on
happening.
the iPhone 4S and the 4, these shields are detachable. So there's no reason to not take off the shields. Of course you're going to take off the shields. All right, you can just drop that in there now.
Okay, so we've got this.
Yep, we'll
and
be able
it's
to
all kinds of
recognize it
encrusted.
because it's the 4S.
Okay. I'll throw it in.
Okay, so here's one here. Now this has come to me, and this is, I think, the future of, you know, maybe you don't want to do water damage because it is, you know, it's a rabbit hole, you know, no rabbit hole, so no, you know. So let's, this is an iPhone 6. This shield is just a sticker, so I just took that off.
Okay.
This shield we will have to desolder.
Okay.
This shield we will desolder.
Okay.
And then when I look at this phone under the microscope, I can kind of make a decision here. And when I look at this phone, this is the top of the board. That looks good. Whoops. This power flex area looks good. Bluetooth Wi-Fi area looks good. I don't see any frank corrosion or oxidation. This all looks really untouched by water at this side of the phone.
Okay.
So I am going to leave this shield, which covers just the processor, and it has like a kind of a thermal paste. I'm going to leave that alone because I don't think it's necessary or worth it. All right, so now how do we actually desolder the shields? So they are connected on here by these joints. And for most of the phones, Apple did use a relatively low melt solder. So they're
probably specifically to make rework easier for them.
Mm-hmm.
Because we're not the only ones that's assembling these things.
Right.
Apple will run it through the factory. They'll find a defect. They'll actually do board repair in the factory.
Right. So I'm going to stick it in the Omni vise.
Okay.
And then this particular shield tends to be a little bit more difficult than some of the other ones that are out there. So let's go ahead and give me some hot air. So I'm just going to kind of heat, and I'm really just listening for like this shield to pop. You hear that pop, pop, pop?
Yeah. And you're using the rework station hot air gun instead of a soldering iron because why?
I could use a soldering iron. You know, I could kind of go through, and I used to do that. This for me actually tends to be faster. And you know,
but if you only have a soldering iron,
if you only had a soldering iron, you could even run the low melt around the edge of this thing with some flux.
Okay.
And that would come right up.
And if you're wondering why are there these shields on here, it's because as these phones run at very high frequencies, they have a lot of electromagnetic frequencies going on between the various components, and so these shields are there to isolate certain parts of the board from other parts of the board.
Okay, so we just took off the logic board shields, and now before I drop it in the cleaner, I just want to kind of do an inspection, because if I do see corrosion in a specific spot, then when it comes back out of the cleaner, I want to like look at that spot, because that is kind of a clue for damage. I also want to make sure that my my removal of the shield didn't like, you know, like fleck some solder around somewhere, or you know, short something out. And that does happen sometimes. A little ball will fly up and short something out. But this looks pretty normal.
We're going to add this board to the ultrasonic cleaning mix.
This is an iPhone 5C. And I want you to tell me, Kyle, as you've kind of looked at a little bit of water damage now, if you see anything that looks like water damage.
Yeah, if you look like at that capacitor on the left, looks like it's got some damage. We've got lots of corrosion on the board.
Yep. I don't know. It'll definitely benefit from ultrasonic cleaning, but you know, right there, that is going to be a burned filter.
All right. So the last board we're going to do, we took out of the phone, and we're seeing some visible damage, even a component that was knocked off in the process of repair. So this is going to be a bit of a project.
So we just desoldered the shields on here, and there's a little bit more focal damage on the back of the board, and let's go ahead and just get them all cleaned up.
So I'm going to throw this in, and this is board number 3 in the ultrasonic cleaning bath. Okay, I've got this on maximum strength. We're going to run it at about 42 degrees Celsius, so there's a heater in here. It's going to heat the water up, and we're going to run it for 4 minutes and see what happens. All right, it's done.
Okay.
I feel like I'm on a cooking show or something. We stuck it in the oven. We're going to take it back out. So let's see what's inside.
All right, so after it comes out, we're going to need to actually brush off the loosened up corrosion. And we also, you know, this is water, so we kind of want to displace the water with, this is just isopropyl alcohol. And this is just a brush. So this one was the 4S. This is the bad one. Now the corrosion comes off, but there's really a difference between corrosion and oxidation, I think. Like if a capacitor is internally damaged so that current goes through it instead of being separated, there's no magical amount of cleaning and should I clean it again? Should I take the shields off? Should I use a different cleaner? No, you can't like bring things back from the dead unless you replace them. So, replace it and then you'll be fine. But you'll see when we look under the microscope that while the like fuzzy green stuff, the corrosion is removed, that you'll still be able to see the like evidence.
So we are squirting alcohol onto here to dry it off. What the alcohol is doing is displacing the water. And then the alcohol has a much higher evaporative point than the water does. So we can set it here with alcohol on it and the alcohol will evaporate.
I usually use compressed air after this to really get it so that it just doesn't smell like alcohol anymore. Then it's ready to go. And the old iPhone 6. No, this one didn't.
So I can see that you are accustomed to having an assembly line here. We do these phones in batches.
All right, now we're gonna let those ones sort of hang out for a second, but we'll go ahead and look under the microscope. This is the one you fixed, the 4S.
Okay.
So let's see.
So how bad is it
Let's
still?
see how bad it is. So you can see that there are,
There's definitely oxidation.
there's oxidation, right? Like this capacitor, this is going to be the negative side. This is where the, sort of current was flowing through it. Same for this one. Same for this one. Same for that one.
Okay.
So this would be something I would consider, it still shows you that even though the corrosion is gone and it has really been cleaned, it has clearly been damaged.
Are we missing a component there?
Yep. So this whatever was on this component is totally
gone.
Totally gone. Corroded on both sides. So it would have been like one of these where it wasn't sort of anchored by this.
So what happened there, the salt got under, attacked the solder joint, corroded it, and then in the process of handling the components,
like
fell
this
off.
one. This
Oh,
will
wow.
be a shorted out capacitor. See how it's not, this one's anchored down because the ground side is relatively okay. Probably same for this one. It's just held in there by underfill.
Wow.
The underfill is the like tar black looking stuff in there.
Sure.
This connector used to look really horrible.
And so that looks good.
So there's this pin here
Is missing.
that we would, well, the pin is still here. So the movement on this joint, look at that.
Okay.
So it's not going to be electrically sufficient right now, but we could take a soldering iron, we could tin that up, we could make that joint again.
So with this joint, the solder itself just corroded so much, just all the solder is gone.
Right.
And that's what's happened underneath a lot of these components is the solder has been eaten away.
Right. Could this board be saved? Maybe, yeah. Right now it would need a significant amount of work. So we could kind of like tally through it. Here's what you just did. So this connector is now insufficient again. So, we could go through here and address these things. Now, one of the most common failures that you might have if you said, let's just dry it out and see what happens. What would probably happen is that you would have a short on the board, so a short circuit. This capacitor, if, its native job is to sort of separate ground from the positive line.
Right.
If it itself becomes internally damaged so that it kind of becomes like a hole in the middle, like a channel,
Right.
Then
you've shorted
creates
out
a
other
wire.
components and
It turns that into a wire, so that entire line and anything else that's on that line is now directly connected to ground. So if you try to power on the phone, the electricity won't be pushed through the entire circuit board. It'll go straight through the little hole in the fence, the bad cap, the short, So how do you find the short? If there is a short on the board, you can figure out what component is it. A lot of them look bad, but probably all of them aren't actually shorted through and turned into a wire. So how do we find that? So what do you think we could do?
So if we know that's the capacitor that's bad, I would look at the schematic and see what else is on that line in the schematic.
What you can do is you can attach it to either a known good battery, and then you'll feel it getting hot somewhere.
Okay.
you know.
Or you can use a IR camera.
Yeah, you can use one of those like fluorescent infrared cameras. You can do this. This is the poor man's way. You know, where you it's that, you know, and I've done that, you know, that's a good way to do it. What I do now is I'll coat it with freeze spray.
Okay.
And then
you'll watch where it...
And then the moment that I connect I'll usually use a DC power supply, and the moment I connect it, something will just turn dark immediately, and that kind of shows you the way. Yep. So let's put this one aside.
Okay.
And let's take a look at
so we
some
know
of these
that
other
phone
ones.
isn't going to work.
So now we're gonna just kind of like look around here to see, are there any water damaged components that we need to address, or anything else that we need to address.
So we've got the phone. Beforehand, we could see it was really bad around this filter and the connector, and now it's looking better, but we still clearly are, you know, have some additional. Is it either gunk in there that's preventing electrical connectivity, or?
Well, it may be okay, but I would, because this phone has very focal damage, so it's very minor, then it makes sense for us to go ahead and just spend a few minutes with the soldering iron to just kind of beef up these connections, and also to spend a minute with the multimeter to sort of, do a quick test. We want to find out if a capacitor is shorting out the board.
Right.
So capacitors normally should not have continuity across them, right? Because one side is ground and the other side is the line. So if we put probes on either end of a capacitor, we should not hear a beep.
Got it.
So let's
we'll switch this over to continuity mode, and we're going to watch.
Okay, so here's a good looking capacitor here, and I don't hear a beep. If I put the tips together, I hear a beep.
Got it.
And if I measure just both sides, I don't hear a beep. If I put one tip on ground on this shield here, one side is ground and the other side is not.
Okay.
So that's a healthy capacitor. Now let's take a look at one of these components here. So right here, this component is not a capacitor. It's not tan. And that's something, you might need to work with the schematic, look up a few things until you kind of develop that just sort of by recognition feel. But it's not a capacitor. This is a filter. So a filter kind of acts like a resistor, and it should have, it's sort of like a bridge in a roadway. So you have to have connection to both sides of the roads on either shore. So should we have continuity across a filter?
Yes.
Yes. So let's see, do we?
Yep.
We do. Okay, so that's good. So that means that is working. What would it sound like if the filter itself was corroded and bad?
You either wouldn't get...
You would not get continuity. Right, so that would be the thing. A lack of continuity when it's a filter. So it's like we're kind of like fishing for opposites here. Right. We're looking to see, do capacitors not beep, which is good. And if filters do beep, then that's good. So let me ask you, what do you think this component is right here that's sort of the component in question?
It looks like a filter to me.
It looks like a filter to me as well. Yeah. I don't know that it is, but I think that it looks like a filter. And we can kind of get a clue as well by just looking at the line. It looks like it goes from this LCD pin across through the filter and then continuing on. It doesn't look like it connects to ground. You can really kind of read it as a map. Mm-hmm. This is the ground. Look how there's a big plane of ground. And the component in question right here, it has a little roadway. It's not connected to ground there. And it's not connected to ground. It's connected to this little roadway there. So it is going to be a filter. So it should, if it's good, have continuity across it. So let's test that.
And it does.
And it does. So that's good. And we should have continuity all the way from here to the LCD pad.
And we do.
And the LCD pin.
All right, so it passes your visual inspection.
Yes.
And a little bit of electrical inspection. So now we're ready to give this board a try.
I think so. Yeah, this one's definitely ready to give it a shot because there's no, obvious thing that would short it out. So we're gonna dry it off.
Okay, that's probably a good idea. And this is just any remaining alcohol.
So I'm gonna just, use that and then It doesn't still smell like alcohol. It feels pretty dry. I could, kind of leave it under a lamp or something. That would probably be a good idea. For today, we're going to give it a try. So I'm just going to stick it back into the housing and throw a screen on it. This is just sort of a kind of loose test.
All right, so we've got this thing back together. We put the board in. We're using a test battery on here. Let's go ahead and fire it up and see what happens.
Okay.
Hey, look at that. Okay.
I see an Apple logo, but
So we
that
have an
doesn't
Apple
mean
logo.
anything until it comes to full
And we've
display.
also got what looks like a test pattern or something on the
Yeah,
screen.
that's typical of like sort of, the digitizer not making good connection. That can be a screen problem, like a test screen will typically be like that.
So this has been an introduction to water damage repair
Right.
in a more intensive fashion than you normally would. And the key lessons to learn out of this is the first thing you have to do is disconnect it from power. You got to stop electrons flowing through the device. And then pull it completely apart. Use
Displace the
alcohol
water.
or displace the water somehow. So displace the water with alcohol.
Yep.
And then remove the board from the device if you can.
Desolder the shields.
Desolder.
You really just know. I mean, just from this example, if you can't desolder the shields, or if you choose not to desolder the shields, then you're really not addressing 80% of the board.
And that's really, if you're running a repair shop, so if you're thinking about taking your phone to a repair shop, you really need to be asking questions. Are they going to be taking the shields off? What kind of ultrasonic cleaner do they have that they're using?
Is it a sweep frequency ultrasonic cleaner? Are the shields coming off? Branson EC, or what are you using to actually do the cleaning?
Detergent. Fantastic. Well, it has been so much fun to have you here. Check out Jessa's channel.
Yes, I've got a YouTube channel where, I just sort of address repairs that are interesting or like a little bit something unusual, or just kind of have fun. I'm going to be making a YouTube kind of a parody video of my time here.
Fantastic. And your channel is?
It's the iPad Rehab channel on YouTube.
Okay, so check out iPad Rehab on YouTube. Subscribe to iFixit. We will have lots more in-depth repairs coming down the pike.
All right. Thanks, Kyle.
Thank
That was
you.
fun.